Your software engineering career is splitting in two. One path leads to a comfortable, respectable six-figure salary. The other path leads to $294,000 a year. And the terrifying part is, most engineers won't even realize they're on the wrong path until it's 5 years too late. This isn't about working harder, it's about which side of a massive economic earthquake you choose to stand on. This raises a crucial question. Is chasing that massive salary a golden ticket, or is it a cleverly disguised trap that leads to burnout? And what's the absolute first step you need to take, even before you open a single tutorial? The answer isn't technical, it's a complete mindset shift. You have to start climbing what I call the abstraction ladder. This means fundamentally changing how you create value. You have to move from being a brilliant coder who translates logic into syntax to becoming an architect who orchestrates intelligent systems to solve expensive, company level problems. That is the real difference. And in this video, I'm giving you the complete picture of AI engineering versus software engineering. Not just the salaries, but the reality of the work. First, we'll dig into the salary data to see why this isn't just a gap, but a great divergence. Then, I'll share a critical cautionary tale to help you avoid the burnout trap. And finally, I'll give you a clear, actionable plan to start your pivot. Most people compare these careers by looking at the average salary. That's a mistake. It's like comparing two cars by looking at a single snapshot in time. It tells you who's ahead right now, but it tells you nothing about who's going to win the race. To understand the real story, you have to look at their acceleration. So, how big is the gap today? The initial numbers are staggering. Data from Built-in and ZipRecruiter for 2026 shows the national average base salary for an AI engineer is $184,757. For a software engineer, $133,490. That's a $51,000 difference right out of the gate, but that's just the starting line. The critical factor is how this gap widens over time. Let's break down the career trajectory level by level. At the entry level, with 0 to 1 year of experience, a software engineer gets a solid start. But an entry-level AI engineer is already looking at a total compensation between $100,000 and $173,000. The premium exists from day one. Now, fast forward to the mid-level with 3 to 5 years of experience. This is where the divergence accelerates. That AI engineer is now commanding between $140,000 and $211,000. The gap is widening. But the most dramatic shift happens at the senior level. A senior software engineer with over 6 years of experience earns a very respectable median wage, around $133,000 according to the Bureau of Labor Statistics. It's a stable, valuable career. But for a senior AI engineer, that's where their compensation starts. The data shows their total compensation begins at $195,000 and climbs past $350,000. For senior ML engineers, the average total comp is between $294,000 and $453,000. This isn't a gap anymore. It's a completely different financial universe. One path offers stability. The other offers a trajectory that looks like a rocket launch. And here's the acceleration I mentioned. A recent Ravio compensation trends report found that AI and machine learning roles have seen an 88% year-on-year growth. 88%. This isn't a salary bump. This is a fundamental repricing of an entire profession happening in real time. The market isn't suggesting what it wants. It's screaming with billion-dollar budgets what it is desperate for. Looking at these numbers, it's impossible not to feel that pull, that urge to jump on the rocket ship. But if you chase that salary without understanding what comes with it, you're not getting on a rocket ship, you're walking into a trap, and you'll burn out in less than 6 months. Let me tell you about Alex. Alex was a talented senior software engineer, a true craftsman. He saw the numbers we just discussed, took a few online courses in machine learning, polished his resume, and landed a high-paying AI engineering job at a fast-growing startup. He thought he'd made it. The salary was huge, the title was prestigious, and he was on the cutting edge. But within 3 months, he was miserable. He was working longer hours than ever, but felt like he was accomplishing nothing. His entire world, a world built on the satisfying certainty of logic and code, had been turned upside down. Why did the job that looked so good on paper feel so fundamentally broken in practice? As a software engineer, Alex lived in a world of deterministic systems. His life was organized around 2 week sprints, clearly defined Jira tickets, and predictable deployments. If there was a bug, he could trace it. If a feature was requested, he could build it. There was a direct, tangible relationship between his effort and a finished, working product. He was a builder of clocks, intricate, complex, but ultimately predictable. His new role was completely different. His first major task wasn't build an API endpoint that does X. It was reduce model hallucinations on the customer support bot by 5%. There was no blueprint. There were no clear steps. His days were no longer about writing code that followed strict logic. They were about running experiments. He would tweak a parameter, retrain a model for hours, and then analyze the results. Sometimes hallucinations would decrease by 1%, but the model's response time would double. Other times, the change would have no effect at all. He felt like he was wrestling with a ghost. His world of clear tickets and predictable deployments was gone. He was no longer building a clock. He was trying to tame a cloud. He was used to the dopamine hit of merging a pull request and closing a ticket. Now his wins were ambiguous statistical improvements that could be reversed by the next dataset. He burned out in less than a year. He eventually took a pay cut to go back to a traditional senior software engineering role, feeling defeated. Have you ever felt that kind of burnout from a job that looked perfect on paper? Let me know with a simple yes or no in the comments. Alex didn't fail because he wasn't smart enough. He failed because he didn't realize he changed games entirely. He was a master clockmaker, suddenly asked to tame a cloud. He was chasing the salary, but he wasn't prepared for the profound shift in the work itself. His story is a critical warning. The money isn't the prize, it's the byproduct. It's the compensation for wrestling with uncertainty and winning. The mistake Alex made was simple. He didn't know if he was a coder or an orchestrator. These are the two identities at the heart of this entire debate. Both are critical, both require immense skill, but understanding which one you are is the key to your future satisfaction and financial success. So, what does this actually mean at 9 a.m. on a Tuesday? What does your Jira board look like? What kind of problems are you solving? Let's draw a clear line in the sand. As a coder, your world is built on determinism. Your day starts with a stand up where you pull a ticket that says, implement a new caching layer to reduce API latency. This is a clear, bounded problem. Your goal is to write clean, efficient, testable code that takes a predictable input and produces a predictable output. You spend your day in the flow, translating complex logic into elegant syntax. Your victory is a passing suite of unit tests, a merged pull request, and seeing a latency graph drop by 50 milliseconds. It is a world of satisfying certainty. You build the machine, and the machine works exactly as you designed it. Now, let's look at the orchestrator. Your Jira ticket doesn't describe a task, it describes an outcome. It says, decrease customer churn by 2% by improving our product recommendation engine. There is no step by step guide for this. Your day isn't about writing code from scratch, it's about architecting a system of systems. You might spend the morning evaluating two different pre trained language models. The afternoon could be spent designing a data pipeline to feed them real time user behavior. Your code might just be a configuration file that orchestrates how these AI components interact. Your victory isn't a single merged pull request. It's seeing a statistical trend move in the right direction over the course of a month. It is a world of managed probability. You don't build the machine, you guide it, you tune it, you orchestrate its intelligence. This isn't theory. Look at the case study of a Fortune 100 company. Their problem wasn't that their engineers couldn't code, it was that their development cycle was too slow. A traditional software engineer, a coder, might try to solve this by building a better CI CD tool, a deterministic solution. But the AI focused orchestrators did something different. They implemented AI assisted tools like GitHub Copilot across their entire development lifecycle. The result? They bought back 75% of their developers' most valuable asset, time. They compressed a 9-day cycle into just over 2 days. Or consider the Latin American fintech company facing a daunting multi year migration project. The coder approach would be to assign teams to manually rewrite services piece by piece over 8 years. The orchestrator approach, which they took, was to use AI tools to assist with the entire migration. They didn't just finish early, they compressed nearly a decade of manual, soul crushing work into a single quarter. That's not a 12x improvement, that's a time machine. And that is why orchestrators are paid a premium. They don't just solve a ticket, they solve for time, for cost, for massive business level constraints. To help you see how this applies to your own career, I've built a simple trajectory calculator based on this data. You can grab it for free at the link in the description. So you have to ask yourself, which of these two identities feels more like you? Does the idea of a perfectly crafted algorithm give you more satisfaction? Or does the challenge of steering an unpredictable intelligent system toward a business goal excite you more? Let me know in the comments. Just type coder or orchestrator. Be honest with yourself. There is no right answer, but there is a right answer for you. And if that honesty is pointing you in a new direction and you want a guide for this journey, take a second to subscribe. My entire goal here is to help you navigate this massive technological shift successfully with your eyes wide open. If your gut right now is screaming orchestrator, if you felt a spark at the idea of taming that chaos, then the question isn't if you should pivot, it's how fast. Forget a 5 year plan. Here's how you start in the next 90 days. The biggest mistake aspiring AI engineers make is trying to learn everything. They see the vast landscape of neural networks, deep learning theory, and complex math, and they get paralyzed. You do not need a PhD in statistics to make this transition. You just need to prove you can solve a real business problem using AI. The question isn't, how do I learn all of AI? The question is, what is the 20% of effort that will yield 80% of the results and get me noticed by hiring managers? The answer is a focused 3 step roadmap. In month 1, you will master your glue language. For nearly every AI application, this is Python. But don't just relearn syntax. Focus intensely on Python's role as the glue that holds AI systems together. Master libraries like Pandas for data manipulation and Fast API for building the API endpoints that serve your models. This isn't about becoming a Python theorist. It's about becoming a practitioner who can connect the pipes of an intelligent system. In month 2, you go deep on one high return on investment skill. My recommendation for 2026 is Retrieval Augmented Generation or RAG. Why? Because it solves one of the biggest problems businesses have with large language models, making them knowledgeable about specific private company data. Learning RAG proves you can take a general purpose AI and make it a specialist. That is an incredibly valuable skill. If you've already started exploring this, what's one resource for learning RAG that you'd recommend? Share it in the comments. You might help someone else get started. In your 3rd month, you provide undeniable proof. You will build a single compelling portfolio project. Don't just complete another online course certificate. Build a chatbot that uses the RAG technique you learned in month 2 to query a specific knowledge base. For example, build a bot that can answer questions about all the transcripts from this YouTube channel. This single project is your key. A hiring manager will scroll past 10 resumes with the exact same online course certificates. They are meaningless. But when they see a link to a working project that solves a real business problem, the search is over. You're not just a learner anymore. You're an orchestrator. You are proof. And this is exactly what companies are desperate for. A 2026 report from DataCamp showed that 59% of enterprise leaders have a significant AI skills gap in their organizations, and 69% of them are willing to pay significant salary premiums for people with these exact practical skills. Your 90-day plan is a direct path to filling that gap. That $294,000 job we started with isn't for the best coder, it's for the best orchestrator. It's a signal from the market about what it values most, not just today, but for the next decade. So tonight, your first step isn't to open a tutorial. It's to open a blank document and answer one question. Am I a clockmaker or am I a cloud tamer? Once you know that, everything else falls into place. If you're ready to start building that portfolio, Watch this next video on the top 5 AI projects that will actually get you hired.